Hello everyone. So we're going to continue on in our series of the RSLogix controller that we went ahead and created in our last video series, or part of the series. Anyway, going forward, we're looking at kind of our very first rung that the program automatically creates for us. And what I want us to do is just kind of talk about basic bits. We could talk about them as an input or an output. We could talk about them as a Boolean input. Either way, they're simply just an on-off function. So the very first one that I'd like to look at is this XIC that's here, or also known as an examine if closed. And I'm going to go ahead and add that in the program, and sometimes you can drag them and drop them, and then you make sure they're put on the green X. You can also just click, and then it'll add it right after to the right of the icon that's clicked. So if you click here and you want to add another one, it's going to add it right here. It's always going to add it to the right of wherever your selection is, if that makes sense. So means I don't need that many of them. I'm just going to create the one. So the very first rung that we have here is we've created a rung. If we want to create another rung, we can add a new rung up here. Want to add a branch level, that's what this little rung branch tab is here. Either way, what we've done is we've created an XIC. So Rockwell, Allen Bradley have a specific term for these particular functions here, and they're called an examine if closed, or XIC, depending on kind of what you're looking at or talking about. And all that simply is a normally open contact for most of us that work in controls on a normal daily basis. The other one that we look at is like a normally closed feature, and that again would be an XIO. So just the kind of terminology that Allen Bradley Rockwell uses here, in a weird way, it's almost beneficial if you kind of understand this throughout. If you work with a team that knows it more as a, oh, well, that's a normally open or normally closed contact or something like that, again, you kind of throw some of it through out the window. But if you're going to spend a lot of time in the Rockwell Allen Bradley environment, it really pays to know, are we talking about an XIC or an XIO? Either way, so we have our XIC and XIO here, and if we wanted to create, say, we wanted this one here to be a physical input, what we would do is I would suggest you open up your input tab or your input file and you drag the number that you want. So you just click on it, drag it over till that little green X opens up, and you drop it in place. The other way you can do it is if you know exactly what you're looking for, and I'm going to name this one as a Boolean, so it's going to be a B3 and then a colon, usually 0 \1, and then it's going to populate with, I need to set it as a description, and I'm going to call it a stop, PV-HMI. So I'm going to use this as if my HMI sending a stop bit to my function here. And then this one here, if you wanted to add a description for it, you would open it up and you would go edit description, and we could say it's like a start, push button, control panel. So it's kind of the two ways of different naming features, or of how to name them rather, from the data file folder. You can either open it up and drag and drop it, or you can also just type it in if you know what it is. It just kind of depends on your personal preference. I do it both ways in my normal programming every day to day, but excuse me, some people have their own personal preference. So we've talked about now the XIC and the XIO, and what we want to talk about is an output bit. So in our normal user bits, if you will, we have our standards of XIC, XIO, and then an OTE, which is just a standard output. I'm just going to go ahead and click on it and add it. And then the other options we have are an output latch and an output unlatch. And we'll talk about those in just a minute. But the OTE is simply just it's an output function, and all it is in a standard wiring world, this would be considered our coil. our output. So in the PLC, we're sending the output power to this particular coil, drive, relay, whatever it might be, a light, who knows. And in our case, I'm going to go ahead and set this as, and once again, I'm going to right click on it, and I'm going to go, actually, my apologies. We need to set this as some kind of output. So in our case, I'm going to go ahead and open up the data file output, and I'm going to set it as output 00. And then from there, then I'm going to right click on it, and I'm going to edit the description, and I'm going to call it MCR relay. So it's our master control relay being started up when we hit the start button. So this rung here would be true whenever the start push button is pressed. The issue here would be is that whenever the start button is released, this MCR relay would go off. It would remain false. So we just kind of have to read this like a normal schematic drawing, is that if this is true and this is true, then this will be true. If this is false and this is true, then this is going to be false as well. So we have to have both of our features here to be true. Now this is always going to be true unless somebody's pressing the button. This is always going to be false unless somebody's pressing the button. And this is always going to be false unless both of these buttons are, if this one is on and this one is off. One way we'd do that is we'd go ahead and create a branch level. And so we drop our, we just click on this, and then click our branch level button, and then we click on the big red icon on the side here, and drop it onto that little guy there. In this case then, we're going to go ahead and put another XIC in here, and we're going to use our output. So when our output comes on, we're going to hold this branch on until the stop button is pressed. So what we could do is we could open up the output feature, and we could drag this over up here, where our other option would have been is we could have clicked on it here and drug it over as well. Either way, it does the same feature, or it does the same function. Once that is done, we now have a functioning rung that whenever the start button is pressed and the stop button is not, the MCR will come on, and the MCR will maintain holding this closed until the stop button is pressed. This is kind of our standard motor control feature we're running here. If we wanted to have something to maybe tell a troubleshooter or a technician or something like that what we're doing, the best way to do that is to right click on this rung here and go to edit comment. What this does is it opens up a rung comment tab for us. Oops. Just want to double check something here. Yeah. Okay, so we just edit the comment here. And for some reason, mine is defaulting to the output address, so make sure that it's clicked on the file and the rung so that we know what's going on, that it's actually talking about rung. It's talking about ladder 2, rung 0. So the rung comment that I'm going to put in here is the start feature for the MCR functional relay. And so what that does is that gives us basically a comment above our rung that tells the technician that we have this feature or this function allowing that to turn the MCR or the relay on. The next thing that we want to kind of look at is we talked a little bit about latching and unlatching. So if we have a latch on a particular rung, and I'm going to add another rung so we have an unlatch, what this does, and I'm going to go, before I explain it, I'm going to go ahead and assign it to a binary bit, so forgive me. And I'm going to assign it as binary 300, and then I'm also going to do the same thing on my unlatch as well, because I can't have a latch and not have an unlatch. I mean, you could, but you'll never unlatch it if you don't have some type of unlatch. And then I'm also going to add two different buttons here, and I'm going to go ahead and set those as physical buttons. And I'm going to say this one here, this one here. I'm going to go ahead and edit a comment here, edit description, and I'm going to call this one start motor. Okay, and then I'm going to call this one here stop motor. Edit description, I'll call it stop motor. Another place you can also, I just remember this, is that another place you can also add your description is when you open up your input window, if you click on this particular, you click on your particular input output, you can also change the symbol name or the description name within the file bin if you would like to. I usually prefer to do the right click and then edit description. Personal preference. You find what works best for you. Either way, I'm also going to go ahead and add just a quick statement over here on our particular latch feature. So the way this would work is that when we press the start motor button here, it would turn on our latch. Now our latch would maintain on without having to have the sealing circuit up here that we did on our MCR. It would maintain it all the time until the stop motor button is pressed, and then an unlatch would come on. One thing that'll always trip people up, and it has me several times in the past, is that when you look at this MCR feature over here in a functioning program, you'll see both of them green, the latch and the unlatch green. Now that means that that particular bit is in the true state. So it'd be a 1 if you were to look at it as ones and zeros. It is not considered false until the unlatch has been enabled and it has been disconnected from its set, if you will. So what would happen again, like I was explaining, is you hit the start motor button and the latch would come on. When you hit the stop motor button, the unlatch would be enabled and thus disconnecting both of these. And that would be the simplest way to do that. With that being said, I often caution a lot of people in putting latches and unlatches in programs. They work great, they look great, they function great. The problem is that sometimes we'll put a latch in one routine or ladder, and the next thing you know, the unlatch is somewhere buried deep in the program, and it makes it very difficult for people to troubleshoot and understand. So I often caution and suggest that stay away from latches and unlatches. They do have a time and place, I won't deny that, but I often caution the usage of them. So if you come across a need for it, I highly suggest you use it, but I would strongly encourage you to definitely rethink it and kind of lean more towards the idea of having a sealing circuit with this particular type of setup here on rung 0. If you're in the instance of you're the programmer, you program it how you need to, or how your company says you need to, or how your engineering team does that. However your standards are set. There is no set way on how to do this. There just are better ways than others. Just in the back of your mind, if you're the programmer, always think, who's going to troubleshoot this and how hard is it going to be for them to understand this? Just a couple of words of advice on that. So anyway, thank you all for watching, and please stay tuned and continue for the next set.